Today we're going to talk about units and prefixes. There are two systems of units of measurement. The U.S. customary system, which is what you will generally hear in the United States, that includes like the inch, pound, mile, miles per hour, gallons, etc. And then there's the SI or metric system, which is what we generally use in science and in engineering and what the rest of the world uses. So for length, instead of a foot or a mile, you would use a meter. The mass would be a gram. Force would be a newton rather than a pound. Pressure is Pascal. Energy is a joule. Power is a watt. Volume would be meters cubed, or liquid volume would be a liter. Now in the SI system, prefixes are often used rather than writing out the engineering notation. A unit prefix is a symbol that goes in front of the basic unit to indicate a decade multiple or a fraction of a unit. For example, if I have 5 times 10 to the 3 grams, I could rewrite that as 5 kilograms. Where the K is the prefix, it represents or stands for the kilo, which is 10 to the third. So the K is the prefix and the G is the basic unit, which stands for grams. So 5 times 10 to the 3 grams is the same thing as 5 kilograms. So in this chart here, you will see the different prefixes that are used from 10 to the 12, which is a tera. It's represented by the abbreviation at capital T. 10 to the 9th, which is a giga, represented by a capital G, and so on. So if I had, for example, 6 times 10 to the negative 3 meters, and I wanted to replace that with a prefix, I could replace this 10 times 10 to the negative 3 with a prefix. So I look up in my chart and here's 10 to the negative 3. So I could replace that with a milli. The abbreviation is a lowercase m. So this could be written as 6 millimeters. Or if I had 91 times 10 to the negative 12 grams, and I wanted to write that with a prefix, again, go up to my chart. Here's my 10 to the negative 12. So the prefix is a pico, and the abbreviation for that is a lowercase p. So this could be written as 91 picograms. Again, the pico is the p is the prefix, and then the g is the symbol for the basic unit or the grams. There's a few rules for the SI units. For example, symbols of units should not be plural, so you would write 5 millimeters with no S, not 5 millimeters with an S at the end. Symbols should not be italicized. A lot of people like to do that. Symbols are capitalized if the unit is named for a person. For example, a joule is capitalized, but otherwise they should be lowercase. When you're writing the SI units, you should put a space between the number and the symbol. The only exception for that would be angles. So for example, if I wanted to put 5 grams, I put a space between 5 and grams. But if I'm going to put 5 degrees, the symbol for degrees goes right next to the 5. You should have spaces or commas between groups of digits by 3. So 1 million, you'd have a space here and here, or the way we typically see it is with commas. But you can see if you get a whole bunch of zeros, it gets hard to keep track, and that's why we use the engineering notation. Symbols that are derived units with multiple units are joined together by a space or a center dot. So like kilogram meters would be a kilogram dot meter, not kgm or mkg. And the reason being this gets confusing on whether you have a prefix or a unit, so you should put a dot between it or a space. And do not combine prefixes. So like 10 to the 9th is a giga. So you would put that with a G. You do not put a kilo, which is 10 to the 3, plus a mega, which is 10 to the 6 to get a K, whatever this is. It's just not right. So you would use a gigameter and not that. So if we wanted to replace and rewrite these numbers with the correct prefix in place of the engineering notation, we simply need to look at whatever it's multiplied by, whatever decade, and replace that with the proper prefix. So the first one here would be 362, and then we're going to replace times 10 to the third with a prefix. If you go back to that chart, the 10 to the third is a kilo, so that could be replaced with a small k kilometers. Don't forget the unit. You must have the unit, and again the space between the number and the prefix. This next one is 4.5 times 10 to the negative 3 grams. So if you look on your chart, times 10 to the negative 3 would be a milli. So this could be rewritten as 4.5 milligrams. The next one, 1.32 times 10 to the 6. So this times 10 to the 6 could be replaced. If you go to the chart, a 10 to the 6 is a mega. So this would be replaced as 1.32 megaliters. 10 to the negative 6 on the next one. This is a micro. So this would be replaced as 54, and you can replace that 10 to the negative 6 with a microliter. Make sure you have the right unit. The next one, 10 to the negative 9. If you go to your chart, 10 to the negative 9 is a nano, so this would be 93 nanometers. For this last one, 1.07 times 10 to the 12th grams, you can replace the 10 to the 12th, again going to the table, that would be a tera, so this would be 1.07 teragrams. On this next page, what we want to do is take this number, put it in engineering notation, rounded to 3 significant digits, and then replace the engineering notation with the correct prefix. So if we look at this first one, 0.906578 meters, if I were to put that in engineering notation with 3 significant digits, I take my decimal and move it by 3. So I have 906.578, but to round out to 3 significant digits, I'm going to look to the right of the 6. It's greater than 5, so 907 times 10 to the negative 3 meters. And then to replace the times 10 to the negative 3 with the correct prefix, that would be 907 millimeters. For the next one, to put it in engineering notation, I'm going to move it 3 and then 6. So it's going to be 12 when I look at the third significant digit, I look to the right, it's greater than 6, so that I'm going to round up, so 12.6 times 10 to the 6 liters, and then replace the times 10 to the 6 with the correct prefix, which is 12.6 megaliters. For the third one, again, your decimals here, you're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 3.0. Look to the right of the third significant digits. It's exactly 5. So I'm going to round to the nearest even number, which is 4. So 3.04 times 10 to the 9th grams. And then replace the engineering notation with a prefix. So that's 3.04 gigagrams. For the next one, I'm going to move my decimal 1, 2, 3 places. So we have 450. Look to the right of the third significant digit is greater than 5, so I'm going to round up. So 457 times 10 to the 3 grams. If I replace the engineering notation with a prefix, the 10 to the 3 is a killi, so this would be 457 kilograms. On the next one, I'm going to move my decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 56 point. I look to the left of the third significant digit. It's less than 5, so it's 56.7 times 10 to the negative 9 meters. And if I replace 10 to the negative 9 with a prefix, it would be a nano. So 56.7 nanometers. That should be a small n. And then the last one, if I move my decimal, we have 1, 2, 3, 4, 5, 6. So 4.0. I look to the right of the third significant digit. It's exactly 5, so I'm going to round to the nearest even number, which is 4. So 4.04 times 10 to the negative 6. And if I replace liters, if I replace that 10 to the negative 6 with a prefix, it would be a micro. So 4.04 microliters.